Hi, welcome back. This is Professor Ridge, and today's lesson, section 4.6, Polynomial Inequalities and Rational Inequalities. Okay, so let's solve an example. So x squared minus 6x plus 5 is greater than 0. So we got the quadratic polynomial on the left side, and we want it to be greater than 0. Now, a common mistake on this one is you try to solve it like it's an equation, but remember, we can't. When we do inequalities, we're trying to find all the things that make the statement true. So the way we do it, our first step is to find what equals 0. So we call those our critical numbers. So our first step is find critical numbers. This is where it's equal to 0 or where it's undefined. Now for polynomials, they're defined everywhere, so the critical value is just where it's equal to 0. So we're going to find the zeros of the polynomial, set it equal to 0, solve it. What are factors of 5 that add to 6? So 5 and 1, both negative. Set each of those equal to 0 and solve. So I'm going to just shortcut x equals 5 or x equals 1. Okay? So this splits the number line up into 3 intervals. So now, step 2, we're going to split your number line. We're going to plot those points on the number line. On the real number line. Okay. Now note, use open circles if a problem is greater than or less than, and use closed circles for greater than or equal to or less than or equal to. So we're going to make our number line. And you don't have to do it to scale, just make the right relative position, 1 and 5. I'm going to put open circles because it's a greater than symbol. If the equal to was there, it would be, you would do closed circles because equal to would be part of the solution. So this splits it up. We have 3 intervals. We have negative infinity to 1, 1 to 5, and 5. So these are intervals. So the number line gets split into these 3 intervals. Now, there's 3 methods we can use here. We can do what's called the test point method. We can pick a point from each interval and see if it's true or false. And if it's true, every point in that interval will be true. If it's false, every point in that interval is false. Okay, so we can do the test point method. Or we can do what's called the sign. We can analyze the sign method. Or we can think about the graph. What's called the related graph. I should write related graph. Y equals x squared minus 6x plus 5. Okay, so the test point method, you're going to pick 1 point in each interval. So we're going to test, so let's say f of x equals x squared minus 6x plus 5. So if we do pick up a number in the first interval, say 0, So that's 0 minus 0 plus 5. So is 5 greater than 0? True. So the interval negative infinity to 1 is true, so that's part of the solution. Now you're going to pick something in, so this is, say, 2. So 2 squared minus 6 times 2 plus 5, well, that equals 4 minus 12 plus 5, which equals negative 3. Is negative 3 greater than 0? That's false. So the interval from 1 to 5 is not part of the solution set. And then we're going to check f of 6. So 6 squared minus 6 times 6 plus 5, that is 36 minus 36 plus 5 is 5. And 5 is greater than 0? True. So then that means 5 to infinity is true. Okay? So once you determine which intervals are true, that's your solution set. The intervals false are not part of the solution set. So our solution is negative infinity to 1, union 5 to infinity. Okay, if we did the sign method, here's the way we do the sign method. We're going to analyze the sign. So you only do one of these methods. You don't do all three of them. You pick whichever method seems the easiest for you, whichever one you like. Now there's a couple different ways we can do this. I like to look at it the factored form. So we have negative 5. We have x minus 5 times x minus 1. And what I do is I pick the interval. So actually, here's the way I do it. So I have my 1, I have my 5, I have my x minus 5, my x minus 1. I pick a number in each interval, and I plug it in. So that's going to be, say, we picked 0, so we're going to have negative 5. I don't care that it's 5. Negative 1. And then the negative times the negative. So this is the product. X minus 5, x minus 1. A negative times a negative is positive. Okay? If I pick a number in the middle interval, like 2, if I plug 2 minus 5, that's negative 3. I don't care about the number. Okay, I'm just looking at the sign. I put in 2. You got to put the same number in. 2 minus 1 is positive 1. And then a negative times a positive is negative. Usually what I do is I write positive, negative. So this is my product down below here. And then I pick something in the last interval, say 6. 6 minus 5 is positive. Then I put it in the second parenthesis. 6 minus 1 is positive. The product of positive times a positive is positive. Now note, I want x minus 5, x minus 1 to be greater than 0. That's the same thing as saying positive. I want positive, so that's this piece and this piece. So my solution is negative infinity to 1 union 5 to infinity. Okay, so I get the same result. I like that method better than the test point method. And then this method, analyze the related graph. Well, I know y equals x squared is a parabola. The leading coefficient is positive. So if I'm at 1 and 5, those are my x-intercepts. The graph is going to look something like this. And I don't really care how steep, how wide or skinny it is. I know it opens up. Okay, so that's all I need to know. And if I want y to be equal to x squared minus 6x plus 5 to be greater than 0, that means this is above the x-axis. Greater than 0 means above the x-axis. So where is it above the x-axis? Well, it's in this portion, in this portion, right? Because this is above the x-axis. So that means the y values are positive. And remember, we're finding the x values. So my solution set would be negative infinity to 1 union 5 to infinity. So you can do it any of the three methods, whichever one seems the best to you. Okay, whichever one you understand the best. All right, let's try another one. So my first thing is I'm going to find the critical values where it's equal to 0. Okay, so let's see, this one I can do factor by grouping. So let's see, I'm going to get x squared out of the first two. And then out of the last two, I'm going to get negative 1 out. So then I get the x plus 3, the parentheses match, factor that out, x squared minus 1. So x plus 3, and that's difference squares, x plus 1, x minus 1. So x equals negative 3, x equals negative 1, x equals 1. So those are my critical values. Now, that's step 1. Step 2, I'm going to draw my number line. Negative 3, and again, we don't really have to worry about scale too much. We're just going to, the relative left-right position we care about. Now, at these critical values, is equal to part of the solution? Is it less than or equal to, greater than or equal to, or is it just less than or just greater than? And the answer is we got less than or equal to, so that's going to give me closed dots. Equal to is part of the solution. So these three numbers are part of the solution. Now I can do the test point. I can pick a test point in it, or I can analyze the sign. So let's do that way. I like that way better. Actually, to tell you the truth, I think about the graph. I'll show you both the sign and the graph. And then we've got the product. X plus 3, x plus 1, x minus 1. This way is pretty fast. So x plus, if I pick a number in the first interval from negative infinity to negative 3, say negative 4, we plug it in. Negative 4 plus 3 is negative. Negative 4 plus 1 is negative. Negative 4 minus 1 is negative. It's negative 5, but again, I don't care about the number, I just care about the signs, because when I take the product, a negative times a negative times a negative is a negative. Okay, now pick in the middle region, say negative 2. Negative 2 plus 3 is positive 1. Negative 2 plus 1 is negative 1. Negative 2 minus 1 is negative 3. Again, I don't care about the number, I just care about the sign. That's why I'm analyzing the sign. So positive times a negative is positive. So for the product. Okay, then the next interval, say 0. So that's going to be positive. 0 plus 1 is positive. 0 minus 1 is negative. Positive times a negative is negative. And then the last interval, x plus 3 is, okay, let's pick something over there, 2. 2 plus 3 is 5, that's positive. 2 plus 1 is positive. 2 minus 1 is positive. The product, positive times a positive times a positive, is positive. Now what am I looking for? I'm looking for less than or equal to 0, which are negative numbers. So where do we get the negative numbers? So our solution is going to be negative infinity to negative 3, union, negative 1 to 1. Okay? Now if I thought about the graph, let me show you thinking about the graph. Y is x cubed plus 3x squared minus x minus 3. So we got negative 3, negative 1, 1. Now, the idea is the zeros are those spots. We've found it. Leading coefficient, it's a degree 3, so the ends are going opposite directions. All the multiplicities are odd, so that means it goes through. So I don't really care too much about how high and low these things go. It's going to be something like that. And I want negative, if I think about the graph, that's below x-axis. If I'm looking at the graph. So below the x-axis would be this piece, see? And then this piece. So we're going to get negative infinity to negative 3, union, negative 1 to 1. Oh, and it's equal to, so I need a bracket there. For the endpoints, I need brackets. And of course, infinity is always a parenthesis. So same thing here. It's a good thing I did it that extra way. So those are brackets. Alright, so let's solve a rational inequality. So on this one, our critical values are where it's equal to 0 and where it's undefined. Okay, so critical value where it's equal to 0, that's where the top is equal to 0. Okay, so you can just multiply both sides by x minus 3 and the bottom cancels out. So x equals negative 1. And where it's undefined is where the bottom is equal to 0. Okay, so those are our critical values. So step 2, we're going to make their number line. Now note, when it's undefined, it's always an open circle, no matter what. Okay, so even though we got the equal to here, for undefined, we're going to put an open circle there. For negative 1, because the equal to is there, we're going to put a closed circle. If it was just strictly greater than, these both would be open circles. So again, undefined is always open no matter what. Where it's equal to 0, you check the problem. If it's greater than or equal to 0, then it's a closed circle. If it was just greater than, it'd be an open circle. And same thing if it's less than, equal to. Okay, so which way do you want to... Okay, for this one, graphing rational equations is a lot harder than polynomials. So we'll just do the sign method. So we're going to do the x plus 1, x minus 3, and you could do the test point method too. So I'm going to do this, and then I'm going to do the quotient, x plus 1 divided by x minus 3. And again, I'm just going to look at the sign. So if I pick a number in the first interval, say negative 3, negative 3 plus 1 is negative, negative 3 minus 3 is negative. And what's a negative divided by a negative? Say negative divided by a negative, that's positive. Okay, and then in the middle interval, 0, we get positive over a negative. Positive divided by a negative is negative. And then in the last interval, say we do 5. 5 plus 1 is 6, which is positive. 5 minus 3 is positive. Positive divided by a positive is positive. And then what do we want? Greater than or equal to 0, so that's positive or 0. So we're just looking at positive right now. So it's the first interval and the last interval. So we get, our solution is, now be careful, the first interval is closed, the last one's open. So it's negative infinity to negative 1, union 3 to infinity. Okay? Okay, so on this one we got to be careful because now it's not less than 0. It's x over x minus 5 is less than 2. So a couple ways you can do this. You can set it, you can subtract 2 from both sides and then make it one fraction and then go from there. Or you can just kind of use the same technique. You find the critical values. It's where it's, now in this case it's not equal to 0. It's just, basically it's just where it's equal to. Equal to 2 in this case. And still the other one is where it's undefined. So equal to and undefined. So let's do the easy one. Undefined where the bottom is equal to 0. And then this one we're going to multiply x minus 5 to both sides. So those cancel, so you get x equals 2x minus 10. Subtract 2x. Divide by negative 1. So x is 10. So now that's step 1. We got the critical values. Step 2. Okay, so both of them are going to be open circles because there's no negative. So we got 5, we got 10 open circles. And now on this one, we just have to do test values, right, and see if it's true or false. So if I pick f of 0, or if I pick 0, x equals, so we're going to do test values, test points. So if x is 0, that's in the first interval, 0 over negative 5 less than 2, question mark, yes or no? 0 less than 2. That's true. Okay, so the first interval is true. Then we pick something in the between 5 and 10. Say 6. So x equals 6. 6 over 6 minus 5, is that less than 2? So 6 over 1 is less than 2. False. So normally, this is all scratch work. I'll just pick a number. So if I select number in the last interval, say 11. 11 over, so we're going to test x equals 11. 11 over 11 minus 5, is that less than 2? Question mark. So 11 over 6 is 1 point something. So the answer, that's true. Okay, so our solution is we're looking for the true values. So our solution is this interval and that interval. So our solution is negative infinity to 5, union, 10 to infinity. There you go. Alright, so if you just pretty much follow that outline for these rational ones that are not 0, you can find the critical numbers where it's equal to whatever, and where it's undefined, do your number line, and pick test points, take test values, plug it into the original inequality, and see if it's true or false. Okay, and you shouldn't go wrong. And some of them get kind of tedious, but that's the basic idea. Alright, so that concludes the lesson for 4.6. Go to my math lab, complete your exercise there, and I'll see you next time.